Hello, everybody. I hope you're doing well. My name is Kartik Subramanian, and you might have seen some of my videos in the probability statistics playlist. So, for those who have seen those videos, I really appreciate some feedback and making future videos better. So, what is the topic of this video? Well, this video is the introduction to, calculus. And this video and this calculus playlist overall is aimed at making calculus an approachable subject to understand. I know for many people, calculus tends to not be such an intuitive subject, and I think one way to bridge the gaps in understanding, right, or make it easy for people who are currently learning calculus to understand the material better is to kind of explain the material in simpler terms and provide it like another perspective from somebody who has gone through calculus courses in high school and at college. So, without further ado, this video is going to be relatively brief, and we're really going to be talking about what is calculus. So, I guess, before we even start talking about, any of the concepts in calculus, we should at least motivate what is it, right? And there's a lot of ways of viewing it, right? So there's a couple definitions. So, one definition you might have commonly seen is the study of curves. And a second definition is studying change. Now, what do I mean by this? So, for study of curves, right? When people give this first definition of calculus, when they're talking about study of curves, they mean suppose we have like, a function, right? A function is essentially an input mapped to an output. So you might have a curve that looks something like that. And we want to use calculus to be able to explain properties of this curve. Like, for example, we see in this part of the curve here, right? We see there is a decrease, right? But there's also a decrease in this part of the curve. But you might see from the naked eye that, this decrease here seems to be sharper than the decrease here. And calculus gives us a way to quantify that without having to use subjective, like, visual cues, right? So this is one way of understanding the study of curves, right? So we can describe properties of curves like through a mathematical lens or a quantitative angle, right? So that's definition one. And definition two is talking about the studying of change, right? So in our world, right, there are systems that are ever changing. So one example of that could be, say, the stock market, right? The stock market is, always changing, right? So for example, for the Apple stock, right, the price of the stock might go up and down, right? And it could happen in the snap of a finger, right? So we want to study this change, right? And again, just like definition one, it's not enough to say necessarily that, oh, the change from, day one to day 60 is bigger than the change from day 60 to day 70, right? That's just like, not enough, right? So we want to quantify change, right, from different angles, right? And I guess the way to understand definition two is think about something you guys are familiar with. So let's say we're taking a hike. So we have this like, mountain right here, right? And we're down here and this is the top, right? So we're taking a hike, right? And there's curves in the trail and there's parts where you're gaining elevation, right, as you go up the mountain, and there's parts where it's like not as bad, right? So for example, in this hike right here, there's flatter part right here, and there's like elevation gain right here, there's like a sharp gain right here, right, from the looks of this diagram, right? So what can we do with this hike, right? So one thing we can do with this hike is, we can talk about, okay, so you're at the starting point right here and you got to the top. We can talk, intuitively, how much elevation did we gain, right? That's like pretty easy, right? But what if, but when we're gaining elevation, right? Let's say the top guy right here, let's say this is 2 miles, right? So we might say, okay, from the start, right? Assuming that we're at sea level, right? So zero elevation, right? Assuming we're at sea level, right? From here to here, right? There's a 2 mile gain in elevation, right? But your friend might be like, oh, that hike was like really intense. That beginning part was really difficult, but then like, the middle wasn't too bad, but the end was like, okay, it's like just a smooth elevation gain, right? And you might be like, yeah, you felt it, right? Like, for example, if you were going on this part of the trail, right? There's a sharp gain right here, but then, right here is relatively flat and, not as intense, right? So calculus can tell us, right, how drastic was this change, right? So you might say like from here to here, right? The change like seemed pretty sharp, right? So we can use calculus to say how sharp exactly is that change and how drastic really is it, right? So that's the part of studying change, right? So this is the idea of rate of change, right? How much did something change in a given time frame? This is called rate of change, right? So there's two types of change. So there's rate of change. And then the second change that we kind of, elaborated a bit earlier on is incremental gain. So here's an example of incremental gain, right? So let's say you were hiking, right? And your friend was saying, oh, that hike was intense. I felt I burned a lot of calories. Now, let's assume you did not have a calorie counter on you, right? Because, why would you carry such a device up and down? Unless there's, legitimate reasons. But let's suppose that you didn't have a calorie counter, right? So what do? You want to somehow, estimate how many calories you burned from going from, ground or sea level to this 2 mile elevation, right? So one thing you could do is you can try something like, okay, from this part of the curve, right? I burnt 200 calories, and then on the steep part of the curve, oh, that was really intense. So you might have burned maybe 700 calories, and then right here, it wasn't too bad, so maybe 300 calories, and then maybe in like, this segment of the curve, you probably burn like, 500 calories, for example, right? So what you're doing here is you're kind of breaking up this hike into different parts and you're saying, okay, what is the change I observe in each of these parts? And kind of summing it up to get an estimate, right, of the incremental gain. So you can think about incremental gain as breaking up the curve into many little pieces and summing. So that's what this incremental gain type of change is. So we've talked about rate of change and incremental gain as things that we can quantify with the power of calculus, right? So that takes care of definition 2, right? But you might realize, wait, definition 1 is studying properties of a curve and definition 2 is about incremental change. Why is there the confusion as why are there these two separate definitions? And one thing I'd say is this: I don't think the definitions are necessarily separate. I think they're just kind of different ways of expressing the idea of studying change, right? So when we're studying curves, we want to study properties of the curve, right? As I mentioned here, right? And when we're studying change, we want to study, types of change such as rate of change, incremental change, right? And the idea of summing up little pieces, right, to achieve an estimate that you're looking for. So I think honestly, like studying curves, right, and some of these properties that you're looking at from a visual standpoint do relate to intuitions we have about change and, you know, adding up incremental pieces to estimate a quantity that you're looking for. So we'll formalize these, with more like videos as we go through the playlist. But I just wanted to use this video to kind of motivate why calculus is important and what is it, right? Explain simply. So see you in the next video and don't forget to like and subscribe and please leave some comments if you have any questions or feedback. Thank you very much.